right, welcome everybody. Thank you for coming, and again, welcome to our talk for how to view and photograph comets. My name is Aislinn. I am going to tell us a little bit about what comets are and talk about the upcoming bright comet and how we can observe it visually. I joined the team here back in January, and it's been super fun. I started after I graduated, so I did my bachelor's degree in astrophysics at CU Boulder. And then, again, started working here back in January. So I'll go ahead and do the first bit of this, and then I'll pass it over to Soren, and he's going to talk to you guys about how we can photograph these comets. So I'm going to start with what are comets, and just kind of go over some historical interpretations of comet observations, scientifically what they are, and how they behave in our solar system. So to start with the historical context, throughout history, ancient cultures have closely followed celestial movements for timekeeping and just seasonal indications. But because of the unpredictability and kind of chaotic appearances of comets, they've been known and referred to throughout time to be omens of doom or disaster. Many cultures took these celestial bodies to be signs of angered gods and impending war and death because of the interpretation and imagery of comets looking to be like blazing swords in the sky. Comets have actually been called evil stars throughout time, and the word disaster has been traced back to this from the Latin word disastro, the negative Italian prefix dis, and astro meaning star. So disaster means ill-starred event or evil star. Comets have also been blamed for lots of different disasters throughout history. Some examples are during the appearances of Halley's Comet, which have been attributed to many events like the Black Plague in Europe and the destruction of Jerusalem by the Romans in 66 AD. Comets are also the reason why we have the Messier catalog as well. Charles Messier was a French astronomer, and he frequently looked for comets in the night sky. In the process of doing that, he found many nebula and star clusters which weren't comets, and he began documenting these celestial objects as things to avoid when looking for comets. So that's how we get the Messier catalog, which is made up of 110 different objects, all bright enough to observe with smaller aperture telescopes, which is why it's a popular catalog amongst amateur astronomers. Now, scientifically, what are comets? Comets are made up of a nucleus, which is solid ice, dust, rock core. They're made up of the coma, which is a vapor cloud around the nucleus, a hydrogen envelope, which is an invisible hydrogen cloud around the coma, and then the ion and dust tails trailing behind. Comets are icy because they formed out in the outer solar system, and the types of ices can vary from water, methane, ammonia, and carbon dioxide, just to name a few. The composition can also help us decipher between an object being a comet and an asteroid. A comet is the ice, dust, and rock, while asteroids are primarily metal and rock, and they don't vaporize material into gas as they near the inner solar system. The orbits of comets are highly elliptical, meaning they have a very high eccentricity, and they spend the majority of time in the outer solar system. Kepler's second law is that an orbiting object will cover equal areas in equal time. So comets will spend a very long time in the outer solar system, and they'll be near us for a shorter amount of time when they're closer into the inner solar system. There are also two distinctions for comets, depending on how long they take to orbit, and that is the short period versus long period. Short period comets take less than 200 years to orbit, and they come from the Kuiper belt in our solar system. And long period comets take longer than 200 years to orbit, and they come from the Oort cloud. We can also see objects with unbound orbits. Unbound orbits are where the eccentricity is greater than 1, so we get a hyperbolic orbit. and these won't complete the orbit. They'll come in and then they'll just be lost to outer space. And this is what we'll actually see with our upcoming comet. It is unbound. An example of an unbound orbit is Oumuamua. It is the first known interstellar asteroid that came in. It's completely unbound from our solar system. It was just passing through. It was up to 1/4 mile long, and this is not actually considered a comet because it was lacking any outgassing or tails as it came in close to our sun, but it just shows how objects can enter and exit on that unbound orbit. Comet sizes can vary pretty drastically, but on average they're around 6 to 7 miles. A well-known example of this is Halley's Comet, which is 7 miles in size, but the majority of observed comets are going to be smaller than this. The largest observed comet nucleus was actually seen to be 85 miles, and the coma and the tails are on the scale of tens and thousands of miles long, since the debris and gas get left behind as the comet is traveling through space. Because the material is lost, though, as comets sublimate and come through, they also tend to decrease in size as they orbit and approach the sun. Comets that come really close to the sun are referred to as sun grazers, and the nucleus can actually fragment and just disintegrate as they pass through perihelion. For our upcoming comet, we don't know the exact size of it, but it is estimated to be around 1 to 2 kilometers, or like 1.2 miles in diameter. And then here's just a nice picture of Halley's Comet. And it comes around every 76 years, and as it does that, the nucleus does shed around 6 meters of ice and lets those layers off into space. And this debris is actually, it disperses and it causes some of the meteor showers that we get throughout the year. So what we see when we are looking up at comets, as the material is sublimated and it approaches the sun, we're seeing the material as the coma and the tails. We see the light as either reflected sunlight or as glow with the gases because of them becoming ionized. We may also see comets with varying colors because of the chemical composition of the gases in the coma. And we care about comets and looking at them for a few reasons. The debris they leave behind in the solar system can cause meteor showers for us throughout the year. And they can also give us a bit more context for kind of what's going on out in the solar system and some objects that are out in the outer solar system, as well as potential information about how things formed in our solar system. So now we're going to talk about our upcoming comet, the reason we're all here. So the name of this comet is C2023-A3 Tsuchinshan-ATLAS. So the reason why it has this name, so C is for comet, 2023 is when it was found. A3 means that it was the 3rd comet found in 2023. And it was discovered independently by 2 different organizations, so that's why we have this double name at the bottom. So there's the Tsuchinshan Chinese Observatory that found it in January 9th of 2023, and it was also found independently by the Asteroid Terrestrial Impact Last Alert System, ATLAS, astronomical survey in February 22 of 2023. So a little bit about this comet is its closest approach to Earth is going to be October 13th. The best observing time in the northern hemisphere is going to be October 14th to the 24th. The comet will be far enough away from the sun and the sky and might be as bright as the planet Venus. We're not too sure how bright it's going to get yet, but it is predicted to get around -4 for its maximum magnitude, which is pretty close to how bright Venus is in the sky. A3, which I'm just going to refer to this comet as A3, is a comet from the Oort cloud, so it is a long period comet. And since the eccentricity is slightly higher than 1, that means that this comet will not return to its orbit and it won't come back to the solar system. So it is unbound and it will be cast out into space and it won't return. There will also be an apparent anti-tail, and that is just from the, it's going to look like it from the opposite direction of the regular observable tails. And this is because of the relation between Earth's position and our position in the orbit of A3. So it creates this illusion of there being an additional tail pointing towards the sun. And then here we have a chart just kind of showing where it's going to be throughout the next couple weeks. So starting in October 12th, it's going to be pretty low to the horizon. This is for dusk, a little bit after the sun has set. We can see that it's following pretty closely to the path that the sun is going through our sky. So as the weeks go on, it's going to get higher and higher in the sky, but it is going to get fainter the further we go. So there's kind of like this sweet spot of seeing it around maybe like October 14th to 17th or 18th of where it's going to be in a nice place in the sky, but it's not going to be too dim yet. So to view this comet, it may or may not, again, be visible with the naked eye, just depending on how bright it does actually get. But if it does reach its predicted -4 magnitude, we should be able to see it naked eye, but nevertheless, viewing it will be pretty easy with binoculars and telescopes. So for binocular viewing, the larger the aperture, the better. Minimum would probably be around 35 millimeters with a moderate magnification. So something like this 8 by 21. 21 millimeters is probably going to be a bit too small for us to see it. We're not going to collect enough light with these. The 7 by 35s, I think, again, is going to be that minimum that we would want to go. We don't want to go less than 35 millimeters. So we would kind of recommend a nice middle ground, like a 7 by 50 millimeter binocular that will show you that pretty well. For telescope viewing, any aperture is really going to work. And if you use a lower magnification and wide field eyepieces, it'll show you more of the comet and its tails. It should be bright enough, again, for any aperture to work well and give you a good view. And higher magnifications you can use, but the closer you get in magnification, just the more you're going to cut off with the tail. So it just kind of comes down to preference. But yeah. And then for the viewing conditions, so because with that chart I showed you earlier, since it is towards the horizon and it is following the path of the sun, the darkness of the sky, it's still going to have a bit of twilight. So we're not going to have complete darkness when we want to look at the comet. And with its position in the sky, since it is quite low to the horizon initially, we're going to be looking through a bit more atmosphere, and we're going to just have to look a little bit at the clouds because we're going to have some, hopefully have no clouds on the horizon. This is something we have to take a look at and be careful for. But yeah, all right. I'll pass it over to Soren now. He's going to talk about some photography and how we can take some pictures of this.
Thank you, excellent. All right, hi everybody. This is actually probably one of my favorite astronomical subjects to talk about is comets. Over the last 15 years, I've photographed about 22 comets. So this is kind of the target that I gravitate towards because it's something that every night is unique, every comet is unique. And it's always a different challenge. So we'll talk about some of those opportunities and challenges that come with this particular comet and comets in general for future excursions. So one of the first questions is, should I be using a wide field lens or a telephoto lens? Can I use my smartphone to capture this thing? And the broad answer is yes to all of the above. This is going to be a bright enough comet, at least in the initial week or two, that even just taking out your cell phone and pointing it in the general direction where the comet should be, you should be able to pick up that comet as long as you're not clouded out. Using the 2x, 3x zoom, whatever your phone has, if you're able to spot the comet, that should work well and even give you some of that comet tail view. So potentially the only device you need is already in your pocket. If you want to go a step further, definitely, tracking mounts and cameras and little telescopes are fantastic for that. But you don't need to haul out big gear to be able to photograph this thing well. So on that wide view landscape kind of shot, and this is a much dimmer comet, by the way, that was over Denver a couple of years ago. This Comet A3 should be quite a bit brighter than this and quite a bit larger in the sky in terms of apparent size. So look for that clear horizon. If you're going for wide field stuff, whether it's with a smartphone or with a wide camera lens, think about how you want to frame things up, where the comet's going to be on the horizon and what your foreground is going to be. Here in Denver, we are blessed with having the nice Rocky Mountains over to our west, and that's where the comet's going to be. So that should make for some fantastic opportunities for framing up some nice landscape shots, nightscape kind of shots. In terms of going beyond the smartphones, there's the smart telescopes. So I know a few of you have these already, but there's the scopes like the C-Star here, and the Origin and Vespra over there. And these can be fantastic tools for photographing not only deep sky objects like nebula and galaxies, but also comets. I actually went out a week and a half ago and captured this picture of our comet in question in the morning sky with the Celestron Origin. The Origin and the C-Star in the apps they have actually have this comet as an object you can select and target very easily. Some of the other smart scopes don't have the comet as an object in their database, at least at this time. Hopefully they will add it in a few days. But you can always point the scope manually in these cases. In terms of finding the comet, we looked at that chart that showed the general area of sky to look west-southwest just after sunset. And if you use an app like Sky Safari or Stellarium that has this comet in the software, then you can also get the right ascension and declination. So if you're using one of these other smart telescopes where you can plug those numbers in, or if you're using a general computerized go-to scope, you can plug that right ascension declination in to be able to find the comet with. So smart scopes, nice easy way to be able to get a more up-close photo of one of these beauties. In terms of some other things to look for, there's going to be some opportunities with this comet for pairing up with some other deep sky objects. So October 15th in particular, the comet is going to be right next to the M15 globular cluster and should be a good brightness to be able to pair up with that object. So you'll need a little bit darker sky for this, and hopefully a clear horizon, but that should make a nice pairing in a relatively wider lens. So this photo of Comet Lovejoy with the Pleiades, was shot with a 50 millimeter lens. to capture the M15 globular and Comet A3. Probably a 100 millimeter, 150 millimeter lens would be an appropriate match.
What date?
October 15. And there'll be, as we go on through the month, there'll be some other close pairings with it as well as it gets a bit dimmer. But that's the first sort of real wow opportunity.
That will be great.
Yeah. So just like you can frame it up with other night sky objects potentially, you can also frame it up with terrestrial objects. So this is the sundial in the Lowry Park by the old airport there with Comet Neowise from back in July of last year. So that was kind of fun to do.
Can I ask you what your setting is on that? Or
Oh.
was that one of these smart guys?
That was actually with my camera. I'd have to go back and actually look at the exposure details. Generally, that is a good question though.
It's so sharp.
Yeah, that is a good question. This is a relatively short exposure. This is maybe 1-2 seconds.
Okay.
And this, I think, is just on a fixed tripod.
Okay.
So there's no tracking involved.
Right.
And because it's a relatively wide lens, you can get away with that with still having sharp stars and a sharp landscape. M5, sorry, not M15. Thank you, Zach.
That was the close approach on the 15th he was talking about.
Yeah, I'm getting my numbers mixed up. So the next thing to think about in terms of focal lengths is sort of a medium range telephoto lens or short telescope like the Red Cat there. This is going to work best as the comet starts dimming a little bit and getting a bit smaller in the sky in apparent size. So more towards the end of the month. Maybe you want to start out mid-month from the 12th for the next week or so after that with a wider field lens, and then kind of graduate to longer lenses as the comet starts to move away from us and fade a bit in brightness and size. This can be a great way to actually capture more detail in the tail structure as well for a lot of these comets. And one of the nice things too is it's still a very lightweight kind of setup. You can use something like just a little camera tracker mount like I have here. This is actually my primary comet photography setup right there. So it all fits in a backpack. I can just throw it in the car in the evening or in the morning for those morning comets and be set up in just a few minutes. So makes for a nice comet chasing rig.
What kind of exposure times are you typically looking at?
Yeah, so
Relative to dark sky?
yeah, in terms of exposure times under a dark sky, potentially you're looking at a couple of minutes exposure time. And we'll get to that point with this comet later in the month as it gets further from the sun. I think initially for, October 11th, 12th, 13th, it's going to be so close to the horizon and after sunset and twilight that you're looking at maybe a couple of seconds exposure.
And no stacking?
You can, in fact, stack that way. So even if you're doing a 1 or 2 second exposure, you can do a whole series of those and still do stacking and improve your overall signal to noise ratio.
Okay.
Then we go into the narrower field, the longer focal length kind of imaging. This is best for a lot of the dimmer comets. So after November timeframe, maybe think about using a longer telephoto lens or telescope for photographing this guy. But this can also be a nice opportunity with these longer focal lengths for, again, some more of those object pairings. And this is where you're working with darker skies and can do those longer exposures, 1 minute, 2 minute, 3 minute exposures and do some real stacking. Another approach with stacking, because comets are actually pretty actively moving relative to the stars, is stacking not on the head of the comet, or not on the stars, but on the head of the comet, which is what I've done here, where you can see the stars are blurred, but the comet is well defined and has the tail well defined in that stack there. If you really want to get complicated, you can do one stack on the comet head, one stack on the stars, and merge them together. So that kind of covers the basics for how we would maybe want to go about photographing the sky. We do have potentially a little bonus as well at the end of this month, which is this other comet, 2024 S1 Atlas. This is a sun grazer comet. This was very recently discovered, and this is going to reach perihelion on October 28th. It's going to be passing very close to the sun and may in fact become very bright. But because we just discovered this comet, we don't know a lot of details of its characteristics yet. It could, as it approaches the sun, actually just disintegrate. We've seen that happen with other comets recently. So this is a coin toss as to whether we actually get a twofer this month, or if this one just fizzles out. But we definitely get one good comet coming up in the next week, potentially two over this next month. So keep an eye on the astronomy news websites and our website and emails for that one. With that, thank you so much for your time and for coming, and we're happy to answer any questions.
So on the approach toward perihelion for the second one,
Yeah.
any data on that? On the approach?
They're still, I think, calculating the orbital trajectory of it. That'll get narrowed down over the next couple of days, and I think we'll start to see some of the charts and stuff for that coming out at that time. But that's probably the most relevant slide for the immediate future here. This is off of the Sky and Telescope website, and we sent around the link for that with the email this morning.
To get the coordinates of the comet, you mentioned Stellarium or one other thing. What was that?
Stellarium or Sky Safari for finding the comet's location. I generally use the Sky Safari app, not only for locating these things, but also for planning my imaging, because you can do nice things like plug in your camera and lenses and see the field of view overlays. So it makes it very handy for doing some of the planning for photography.
The other site that I found was the Sky Live.
The Sky Live is also a good one, yeah. All right, folks, the store is yours to browse around and continue to ask questions. Thank you so much for coming out.
Yeah, thanks, Ron.
Thank you.
Thanks, sir.